Hello guys, this is Monjima and this is going to be a little different today because today we're going to talk about a survival prediction based project that might be a very good start for any data related career. But before we start, let me remind you to hit the subscribe button and the bell icon first. You will find it just below this video screen. And also do not forget to watch this video till the end because this is going to be one effective learning today. So let's just get started. So this is the ship of our prime concern today and we're gonna discuss about it and do some analysis on its dataset. So basically here I predicted possible survival cases for each passengers that whether particular passengers holding a specific passenger ID did survive or not. So here we go. First, I imported all the basic and necessary libraries to work on exploration of data, and we then definitely need a dataset to work on, right? So here I inserted the train dataset along with the test dataset. And as well we printed out the first 10 rows from our train dataset. So by this command, we actually print the data frame and we also get to mention the number of rows we want to see within the bracket. So we just printed out the first 10 rows of test dataset as well. But we still do not have any idea about the number of rows and number of columns they have, right? So here it is. The number of rows in train dataset is 891 and the number of columns in train dataset is 12. So our train dataset does contain 891 rows and 12 columns. And then we get a rough idea about our dataset, about our train dataset specifically, which means that we get to know about the data types of our columns, and also we get a small hint about missing values for a specific column. And then we put this command, this describe command, to have a neat and clean statistical idea about our train dataset. It actually gives us information in 5-point summary format, means it prints out all the minimum value, first quartile value, median value, third quartile value, and then maximum values for each column of our dataset. And in addition, it also gives us the total value counts for each column, each individual column, and we get to see that the each column does lack some data entries because this was supposed to be 891, right? Because our train dataset does contain 891 rows. So we will deal with it later. Next, we come to see if we have any duplicated values contained in our data frame. So luckily we do not have any duplicated values existed in our dataset. So I guess that's the good news. And then we come to the most important part of any project or analysis, that is missing values. So we see that the column cabin has 687 missing values. Oh, by the way, I forgot to tell you that cabin column is the categorical variable. So we did not get any record of it here because it shows only the information about numerical variables. So we see that the cabin has 687 missing values and the H column has 177 missing values, whereas the number of missing values from embarked column is totally negligible, which is 2. And we see this better from this data frame below along with their percentages. Well, cabin column explains 77% missing values of the whole dataset, whereas H column holds only 19% of missing values and embarked column explain only just 0.2% of the whole missing value cases. And we can get a far better idea about missing values from these visualizations. First, we prepared the matrix plot to see all the missing values from individual columns. And we see the stripe patterns under any column whenever it lacks any data value. And as long as we are on this missing value context, which column actually contains the bigger amount of missing values, we can see it from the bar plot representation. We clearly see from this visualization that here cabin column creates a bigger gap in our whole dataset because it does contain really a great amount of missing values than others. Well, as we have just observed the amount of missing values, we cannot now keep them at rest, right? So we need to deal with it. We first create a column named age mean by replacing its missing values with the mean value, and we clearly see the difference it makes in curves after getting replaced, and it shows a better curve than before. Here blue curve represents the data points after getting replaced by the mean value, and the green curve here represents the data points without getting replaced by the mean value. So filling up the spots of missing values does change the curve, right? So now that we have dealt with missing values for each column, if you remember, we still have cabin column with missing values to deal with. So here we really do not do anything else with it. We just drop it along with all the other unnecessary columns like name, ticket, fare and passenger ID from our train dataset as well as from our test dataset. We drop these columns from our test dataset also. And this is how our train dataset looks like after removing all the irrelevant columns from it. So as we are almost done with the theoretical analysis of data, now we will try to explore the data through some visualizations. First, we start by value counts of non-survived and survived passengers. We see here from this data frame that 549 out of 891 passengers did not survive, whereas 342 out of them managed to survive from the sink. And we can also see the percentages for the survival counts. So we now try to represent them using a pie chart where we see that the bigger portion of that pie holds data for non-survival cases, which is nearly 62% of the whole passengers list, and 38% survived cases are assigned to this smaller slice of pie. And we also have their individual value counts here in this index. So now let's have a good survival picture from each column of our data, which I have done using count plot. So this is our count plot visualization where I created 4 subplots within it. So we see in the first plot that 0 in every picture represents the non-survival cases, and 1 here represents the survival cases. Where in the first plot we see that male passengers did die more than females, and also on the other hand female passengers did survive more than males. Also here in the second picture we see that passengers having absolutely no siblings or spouse did die more than others, and also I guess having no one is a great deal here because they also survived more. And we see survival counts from other columns as well, like parents and child column from embarked column. So this was our count plot visualization. And then I prepared bar plot as well to see how many non-survival cases did occur within each column. I mean, we can see that from P class, the passengers from third class died more than that from first and second class. And we have bar plot for other columns as well, like for sex column, for embarked column, and then parents child column, and then for sibling and spouse column as well. So this was our bar plot representation of each column. And then we took a little help of cross table just to show data values for each possible pairwise columns, and we just wish to see how does individual survival value count comes from other features. So we see that here passengers coming from third class died more than others coming from first or second class. We can clearly see the numbers here. And we can also have total counts of every rows and every columns and the whole passenger count here by summing up either all row totals or all column totals. So we proceed further and see cross table of other pairwise columns like its survival counts with respect to male and female passengers, and then survival cases for siblings and spouses column. So as we have just seen all the pairwise passengers counts, now we try to fit them in just one big table named pivot table. So we can see all the value counts here, and then we surely prefer some visualizations. So I have as well created plot for this pivot table. What I have done actually here is I have prepared heat map visualization of target variable over multiple variables, And then I also created line plot for better understanding. And with that, we finish our data analysis part and start preparing data for fitting our suitable model. So we just import some required libraries for data preparation, and we just convert these two relevant categorical columns into some numerical values, because it is quite out of the picture to involve categorical values in fitting a model. So we just do it, and we do it for both of the datasets, train and test. And you can see here from this data frame result that values from 6 and embarked columns have been changed to some numbers which are clearly numerical values. And then we set our values for training first, and then the target variable, and then we set values for testing too. And then we just normalize our train and test data values using standard scalar object. So our training dataset is now almost ready to be used to fit a model. So finally it is time to apply our machine learning ideas and prepare the model. And here I apply 6 types of machine learning algorithms just to find the best fitted model for our data. We just feed them one by one and calculate the R-square value for each one of them and see which algorithm produces the maximum accuracy score. So here we go. We first import our required libraries from scikit-learn module, and we just feed them one by one using first predictor variables xtrain and the target variable ytrain. So we do this and print out the accuracy score for each model here. So just to clearly get the idea, I have sorted these accuracy scores in descending order into this data frame along with their model name. And also I have prepared bar plot for this. So we see that the decision tree and the random forest models do give the highest accuracy score. So we're just gonna use random forest model for our prediction. Well, we then finally predict it using the predict function of random forest object. And at this stage, we definitely use the test variables, xtest. So well, now that our prediction is done, we finally put my final prediction here along with the corresponding passenger IDs. So my prediction says that passenger having passenger ID number 892 did not survive, and again passenger holding passenger ID 895 might have survived, and so on. So we then finally save our predicted data frame to a CSV file and we name it Survival Prediction of Titanic. And this is the end. So if you like this project and my way of explanation, do give this video a like. For more videos like this, hit the subscribe button and the bell icon. So see you in my next video. Till then, bye bye.